Hey guys, this video we're going to finish up chapter 12. This one's about combinations and probability. So we'll look at the difference between combinations and permutations. Permutations was last time, order mattered. Sneak peek, combinations, order does not matter. And we will calculate combinations in some application situations. So, difference between combination and a permutation is order. Permutations, order matters. Combination, it does not. So the first thing you're going to ask is, does order matter? Order. And it matters for permutations, it does not for combinations. Because you're just combining different things. Like, usually like with a recipe, especially if you're baking and you just combine all the ingredients, like you mix it with a not a blender, but a mixer or a spoon or whatever, you're mixing them all together. It doesn't matter what order you combine them. But a permutation order does matter. So a 10-member club will elect a president, vice president, and secretary. How many different ways can they be filled? So, in this case, does order matter? The answer is going to be yes, because we'll just say that the first person will be president, the second person will be vice president, and the third person will be secretary. That will be different than if you mix those people up. So, yes, order matters, which means it's a permutation. And then the first number is how many you're choosing from, and the second number is how many spots you're filling. And there are president, vice president, secretary, so that is 3. So it's a 10p3. So we can use our calculator. Remember, permutations, it's actually super easy. We did this in our last video. You just have to have, this 3 tells you you're going to have 3 spots, and you just count down from 10. That's the shortcut for permutations. But your calculator has a different kind of shortcut. Has this all built in. You don't even need to remember that. We just need to go to probability. So that's option, and then scroll over to probability. And there's our P for permutation. So we'll do a 10p3, which that will be the same thing as 9 times 8, 72, times 10 is 720. Same answer if you did it by hand or calculator. Doesn't really matter. Two of the members will attend a conference. How many different ways can 2 people attend? Well, in this one, order does not matter because it's just 2 people going. Doesn't matter who's first and second unless you're determining like who drives or something, but that doesn't really matter. So no order does not matter, which means it's a combination. And again, there's 10 members, 2 of them are going. There is a formula for it. It's also in the calculator, but it's really the same thing. Is you've got 2 spots, so we're going to fill those 2 spots. We have 10 and 9. And then the only difference for combinations is that there's a denominator for these. The denominator, you just count down with the other number. 2, 1, and it should match up. You should have the same number of numbers, digits, or spots that you're filling up, basically. So 10 times 9 is 90, over 2 is 45. We can do that on our calculator as well. That'll be 10c2, 45. So there are formulas, but this is basically the shortcut of the formula. It's just the way I showed you here. Alright, so order matters for permutations. It does not for combinations. That's the biggest takeaway for this lesson. Order matters for permutations, not for combinations. So combination is a distinct set or group of objects without regard to their arrangement. Order does not matter. So there's our symbol. We already used it. Combinations are groups. And then, like I said, here's the formula, but I already showed you the shortcut, which is way easier than the formula. Use your calculator or the shortcut to do it by hand also, with just marking out the number of spaces. All right, 8C3. So that means 3 blanks. Since there's a C, we're filling in the bottom. The way I remember the difference between C and P, when you look at the letter P, there's not really anything in the bottom half of the letter, but a C does have stuff in the bottom half. It's kind of a dumb way to remember, but it helps me, so hopefully it can help you. So we do put things in the bottom for C because it's got the hook down there in the bottom for the C. And then 8 is the numerator. We're counting down from 8, so 8, 7, 6. We just fill it up. Now, as you're multiplying or solving this, you can simplify anything in the numerator with any of these in the denominator. So, in my opinion, easiest way to go about this is 3 times 2 is 6. It's just going to cancel out that 6 right there. 7 times 8 is 56. Should be our final answer. You can also check it with your calculator. 8C3 56. Jen has 10 different cut flowers, which she will choose 6 to do a floral arrangement. How many different ways can she do so? I don't think it would matter what order she sticks them in. So we're just looking at combinations, 10, and we're using 6 of them. So this one will be a little bit longer by hand. 4, 5, 6 spaces. Remember, we count down. 10, 9, 8, 7, 6, 5. And then the denominator, because it's a C, there's stuff down there, we just count down from 6, the second number. And you can reduce this however you want. So since there's a 6 and a 5, you can cancel the 6 and the 5. Since there's a 4 and a 2, 4 times 2 is 8. You can cancel the 8. And then the 3 can reduce with a 9. And now there's no more denominators. These will never be fractions. It will always work out to be a integer answer, so, or whole number answer. So 10 times 3 is 30 times 7, or you could do 7 times 3 is 21 times 10 is 210. Or you could have just pulled out your calculator and typed in 10C6 210. You want to purchase 5 of 7 CDs that you like. How many ways can you select 5 CDs for the purchase? You get to keep these forever, so the order doesn't matter. We're doing a combination then, 7C5. By hand, that means 5 blanks. 7, 6, 5, 4, 3, over 5, 4, 3, 2, 1. And then 5, 4, 3 cancels 5, 4, 3, 2 cancels the 6. Final answer here is 21, 7 times 3. Or, of course, you could have just done calculator. Or you can check your work at least. 21. Alright, here we've got a dinner party. You have 10 different bottles of soda, 8 different bottles of juice. You want 4 bottles of soda and 2 bottles of juice. How many ways can you choose your beverage? So this is some combinations here. We're going to look at soda and we're going to look at juice. For the soda, we have 10 to choose from, and we're going to pick 4 of them. And then for the juice, there are 8 different kinds of juice, and we're going to bring out 2 of them. Now, the order you pull these out, so I don't know, this is kind of weird the way this is set up, but maybe you're at the store and they have 10 types and you're going to buy 4, or, yeah, 10 types of soda, you're going to buy 4, and they have 8 types of juice and you're going to buy 2 of them. That would make more sense than just having these bottles somewhere, and because, I don't know, whatever. But the order you pick these things doesn't matter. So that is a combination. Doesn't matter because you're going to have all of them available, probably sitting on the table or in the fridge or whatever for your guests. So we have a 10C4 and an 8C2. Now we're looking for all those different combinations also. So this is also using the counting principle, which means we're going to multiply these things together at the end. And you can do that all in one step on your calculator. You can do 10C4. We'll put some parentheses around it just to make sure. I don't know that it would matter, but when in doubt, use parentheses. Times, and then our other one is going to be an 8C2, I think, right? Yep. Multiply it out, 5880. At a Chinese restaurant, dinner for 8 consists of 3 items from column A, 4 items from column B, 3 items from column C, and columns A, B, and C have 5, 7, and 6 items respectively. So for item from column A, we have 5 choices, and we get to pick 3 of them. Again, order doesn't matter because it's just what they're going to bring to your table. For part B, again, order is not going to matter, so there are 7 choices, and you get to pick 4 of them. And then from column C, so this could be like entrees and sides and desserts or whatever it works out to be. Again, order doesn't matter. There are 6 to choose from, and we get to 6 items on the menu. We get to pick 3 of them for the table. Again, this is the counting principle again, so we have to multiply all these options to get our total. So that's, again, let's use parentheses just to be safe. 5C3 times 7C4 times 6C3. That's going to do all our calculations and multiply, so this is our final answer. 7,000 options. Alright, so now we're going to look at using playing cards. What's the probability of selecting 2 picture cards? And it specifies that picture cards are just jacks, kings, and queens without replacement. So the choosing 2 cards, so 1 picture card and another picture card. So there are 4 jacks, 4 queens, 4 kings. That's 12 picture cards without replacement. Means now we're going to multiply that by there's 1 less card and there's 1 less picture card. So we're just multiplying that out. 12 times 11. And then 52 times 51. And then we can reduce that by typing it as a fraction and get our decimal or whatever we want to do. So it's 11 over 21, or if you wanted a decimal, you can change it. It's about 5%, but 11 out of 221. All right, so now using the combination formula. So our combination formula means that there are 12 face cards. We're trying to pick 2 of them out of 52 cards that we are trying to pick 2 of. So on our calculator, we can do come on, C2 as our numerator, and we can do 52 C2 as our denominator, and look at that, 11 over 21, or 221 rather. Same thing. So that's a different way to use combinations to help you figure that stuff out. Total number of 2 picture cards that we could choose, and the total number of 2 cards that you could choose altogether. All right, in your wallet you have 8 bills, 4 5s, 2 10s, and a 20, and a 50. You select 2 at random, determine the probability that you select 2 $5 bills. So the probability that you select 2 $5 bills, so the probability of getting 2 5s, a 5 and a 5. So the ways that we can get 2 5s, there are 4 of them to choose from. We're trying to pick 2 of them. And then we have the total number of ways that you could pick 2 bills out of it. The total number of ways of picking 2 bills, there are 8 total. We're going to pick 2. So on our calculator, that's all we got to type in is 4 C2 over 8 C2. And that's 3 out of 14 chance. And if the decimal would make more sense to you, you just change it fraction to decimal. So about 21.4%. A club consists of 4 men and 5 women. 3 members are selected at random to form a committee. What's the probability that the committee will consist of 3 women? So we're going to look at the probability of getting 3 women out of, so how many ways to get 3 women? And then how many ways to get 3 people total? So 3 women, that would be, there's 5 to choose from. We're trying to pick 3. And then total people, there are 9 to choose from. And we're choosing 3. So on our calculator, we have 5C3 over 9C3. Sometimes people say choose. You'd say 9 choose 3 or 5 choose 3, something like that, but or combine or whatever. But I just like to say C or P to distinguish if it's a permutation or combination. All right, 5 out of 42. And again, if you wanted a decimal, just change it. About 12% chance of that happening. All right, here's another one. A committee of 4 is randomly selected from 7 teachers and 8 students. What's the probability that it'll be all 4 students? So there are 8 students to choose from. We're picking 4, so we're doing 8 choose 4, or 8C4. And then our total, that we have 7 teachers and 8 students, so that's 15 total. We're making a group of 4. So again, 8 C4, oops, over 15 C4. Over 39. Or again, if you wanted a percent or a decimal, just change it. About 5% chance of that happening. Same situation this time. It's probability of 2 students and 2 teachers. So again, we have 2 things here. So we're going to look at how many ways to pick 2 students. And then it's going to be like a counting principle here. We're going to do the times the ways to pick 2 teachers over the total. So to pick students, just like we're picking 2 students, so that's picking 2 out of a group of 8. Oops. Needs to be a little bit smaller. And then for our teachers, we're picking 2 out of the group of 7. For our total, we're getting groups of 4 total from the group of 15, 7 teachers, 8 students. And we can do that all on our calculator again. Let's get our fraction set up. Our numerator is going to be 8C2 times 7C2 over 15 C4, because we're choosing 4 people total. So it's 28 out of 65. And if we wanted the decimal, change it to a decimal, 43, about 43% or whatever. All right, last one. We're looking at coin collection. It's got 8 silver dollars, 7 quarters, 5 dimes. He plans to sell 8 of the 20 coins. 8 plus 7 plus 5 is 20. If he selects 2 coins at random, what is the probability that selects the coins, not 2 coins? What's the probability that he selects 3 silver dollars, 2 quarters, and 3 dimes? So the 3 silver dollars, 2 quarters, and 3 dimes. We're looking at that as there are 8 silver dollars, and he's choosing 3. So there's 8. He's going to pick 3. For the quarters, there are 7, and he's going to pick 2. And there are 5 dimes, and he's going to choose 3. So all of that is our numerator. And then our denominator is just how many different ways can he choose those coins. And we are choosing a total of 8 out of his 20. And I am just going to type all of this into the calculator and let the calculator do all the work. 8C3 times 7C2 times 5C3 over 20C8. 392 out of 4199. And again, if you wanted the odds of that, this is such an obscure kind of question anyway, but if you wanted it as percent, just change it. It's about a little bit over 9%. That's it. You can find your worksheet in the Files tab and get it submitted. As always, post your comments and questions, and see you next time.